Hello and assalamu alaikum everyone. Hopefully you guys are doing well. So welcome to lecture 4 of simulation and modeling. I am with you Shajadur Ahmed. So today we are going to discuss about a simulation of single channel queue, and also there is another part. You can see that lecture 4 is actually divided into two parts. In part 1 we will discuss about single channel queue. That means we have said single channel queue is a system with a single queue and a single server, and then in second part we will discuss about double channel queue. That means a system with a double queue and a double server. So let us forward with single channel queue. This is something very interconnected with our last lecture, so whoever follows the last lecture will be beneficial in this lecture, because some of the things and some of the topics will be repeated in here as well, and we'll see so as you can see that there is a scenario, and from the scenario you can see that from now on whatever simulation we are going to do, we have to start with a scenario based on a paragraph or something. So as you can see that we are dealing with single channel queue. That means there should be only one server. So you can see this is the server. This is a scenario of a super shop. So assumption, all the simulation will start with a set of assumption. Only on checkout counter, that means there will be only one counter which is act as a server. Customer arrive at the checkout counter at random from 1 to 8 minutes apart. That means the random time or interval time is minimum interval time is 1 and maximum interval time is 8. And then it has been said that each possible value of interval time has same probability of occurrence. So what does it mean by this line? Actually it is meaning that you can see that there are 8 different interval time, isn't it? 1, 2, 3, 4, 5 and 8. So there are 8 different interval time. All the interval time actually have same probability of occurrence. প্রত্যেকটা ইন্টারভ্যাল টাইমের ঘটার সম্ভাবনাটা সমান। সো সম্ভাবনাটা কত সেটা কিন্তু বলা নাই। সো হাউ ডাজ উই ফাইন্ড আউট হোয়াট ইজ দ্য প্রবাবিলিটি? সো উই ডু এ ক্যালকুলেশন. We know that the total probability is 1 and there are 8 different interval times, so we have to divide it 1 by 8, so we can find something like 0.12 and so on. So that means the probability of each interval time is 12%. Okay, so if there a probability is given like the interval time is vary from 2 to 6 minutes apart, then how many what should be the calculation? 2, 3, 4, 5, 6. So there are 5 different interval times, so that means 1 divided by 5. You got that? So that's how we actually find out the probability of a interval time. If the term is there given that each possible value of interval time has same probability of occurrence, সবগুলো interval time ঘটার সম্ভাবনা সমান, but you can see in the second in the service time fact that it varied from 1 to 6 minutes apart with the probability shown in table. So the interval time the service time is actually given. That means the system will take minimum 1 minute to serve a customer and maximum 6 minutes to serve a customer. So the probability of each of the service time is actually given in a table. So we don't have to take any panic about the probability, but we have to calculate the probability of interval time. Then what should be our goal? That means what is our actual purpose of this simulation? Our purpose is to analyze the system by simulating the arrival and service. So you can see in this table, in this slide, there are two distribution tables. So what is actually distribution table? Distribution table describe that what is the minimum and maximum interval time or service time, and what is the possibility according to the service time or distribution time. Like for the interval time, it has been said in the previous slide, you can see that each possible value have same probability of occurrence. So the values are 1 to 8 minutes, and you can see the probability is same for each, because it has been said that same probability of occurrence. But for service time it already given, that means you can see that the service time, the minimum service time is 1 and maximum is 6, and they are having different probability. অর্থাৎ একজনের সার্ভিস টাইম যে 3 মিনিট হবে সেটার সম্ভাবনা 30%, আবার 4 মিনিট হবে সেটার সম্ভাবনা কিন্তু 25%। বাট একজন কাস্টমার 1 মিনিট পরে আসবে সেটার সম্ভাবনা কিন্তু 12%, আবার 4 মিনিট পরে আসবে সেটার সম্ভাবনা 12%। ওই যে একটা টার্ম দেওয়া ছিল যে ইজ পসিবল ভ্যালু অফ সেম প্রবাবিলিটি অফ, দ্যাটস ওয়াই ইট হ্যাপেন্স। বাট let me tell you, most of the time we will find it a distribution table totally prepared like this one. Okay, so in that particular time we don't need to concern about what should be the probability, but because we are in the very basic and in the very beginning stage of simulation, that's why it is actually given. So after finding the probability, we have to find out the cumulative probability. So what is actually cumulative probability? Cumulative probability is the summation of previous probabilities, like in this term we summation the previous two probability, দুইটা previous probability যোগফল। সো এখানে যেহেতু একটাই আছে সো এটা যোগফল এটাই, পরেরটা যেটা হয়েছে we have added the previous two, এই দুইটা যোগফল হচ্ছে এইটা, দেন আবার এই দুইটার যোগফল হচ্ছে এই তিনটার যোগফল হচ্ছে এটা, and so on. So we are actually adding the previous probabilities and finding out what is the cumulative probability. So what is the purpose of doing this? Because the cumulative probability should be the last range should be 1.000 exactly, because the probability should be 1, and if it is larger than 1 or smaller than 1, then you have to understand that there is some calculation error in the distribution table, because it should be exactly 1. Okay, and then the next one is random digit assignment. So random digit assignment actually a range. So how does we calculate the range? So suppose the first one is starting from 1 and the last range is 1 to 5, and then the second one will be starting after 1 to 5, that means 1 to 6, and what should be the last range? The last range is 250, and the next one will be started with 251, and the last range should be 375, and so on. So this is how we actually create the random digit assignment column, and you can see that the last range should be as you expect that it should be 1000, but you can see it is actually mentioned as 30. What is the reason? Because we are having a probability that is actually fraction value is 3, that means this after decimal place there are 3 digits, so that's why the random digit assignment range is actually all 3 digit. আমাদের দশমিকের পর তিনটে সংখ্যা, এই কারণেই কিন্তু সংখ্যা মানে রেঞ্জগুলো হচ্ছে 3 সংখ্যা। But you can see that in service time distribution the digit after decimal place is 2, that's why the random digit assignment range is also 2. So exactly in similar way the distribution table is created, and one question can be raised in your mind that how does actually a distribution table is prepared. So it is actually prepared by using some statistics rules like binomial distribution, Poisson distribution, and so on. There are different rules to construct a distribution table, so we'll see it in a particular lecture, but from now till now we can just follow a distribution table which is most of the time will be given in your problem set. So let's move forward, and with this we need also a because we have 2 distribution tables, so that in addition of 2 distribution table we also need 2 set of random digit assignment. So what is actually random digit assignment? We'll discuss it in when we are going to solve the simulation table. You can see there are 2 set of random digit assignment. One for RD means random digit, you can see random digit, it's in short we will call this as RD. So these are the random digit assignments for IAT, that means interarrival time, and these are the random digit assignment for ST means service time. So there are 2 different sets of random digit. So how it use or why it is actually here we'll find out in simulation table. So let's move on to simulation table. So as you can see that this one is actually our distribution table. So in the first scenario, we have seen that we have been asked to prepare a simulation table for 20 customers, so that's why it is 20. But you can see there are some cut down because to make it easier to understand. So let us start row by row. So we'll start with the first customer number 1. So let us first of all discuss about the columns. So first of all, the customer or student, sorry, should be customer, and then the interval time, random digit for interval time. These are the set of random digits that have we seen in the last slide, and from the last slide we have picked some of them. Okay, so but that's how we actually use. But after that, interarrival time, then arrival time in the system, then random digits for service time. These are actually picked from the set of random digit for service time in the previous slide, and some of them also are present here. Then service time, and then service begun time, service end time, waiting in the queue, how many times actually a particular customer wait in the queue, service time, server idle time, and time spent in the system. So how many time a particular customer is spent in the system. So we'll begin with customer 1. So as we have already discussed that there is no interval time of customer number 1, because when the customer 1 enter into the system, then the simulation clock is start tick-tocking. So to find out a interval time, there must be at least 2 customers, and the difference between the arrival of 2 customers is actually called interval time. So when first customer enter into the server or system, there are no one to compare what are the difference between the interval arrival time. So that's why please remember, it is always that the interval time, the first customer does not have any interval time. So that's why we are actually using hyphen. Random digit for interval time also hyphen, assigned by hyphen, and the interval time also assigned by hyphen. And the arrival time is 0. So always the arrival time of customer number 1 is 0. But if the scenario is started with that the system will open at clock time 8 a.m., then the arrival time of customer should be 8 a.m. Okay, so we'll discuss it in later, but let us now consider that the first customer arrival time is 1, and then we have picked the service time of first customer. First customer does not have any interval time, but he or she must have a service time, and how many time he need to take the service from the system. Okay, so it has been given that the interval time of the random digit for interval time of the random digit for service time of first customer is 84. So if it is 84, then we'll go for the go into the distribution table. আমরা আগে হচ্ছে random digit for service time টা ইউজ করছি, এই টেবিল থেকে আমরা সিকোয়েন্স অনুযায়ী বসায় দিয়েছি। সো আমরা দেখলাম যে সার্ভিস টাইমের random digit টা হচ্ছে 84। সো এই 84 আমরা ইউজ করব হচ্ছে, এটা হচ্ছে আমাদের সার্ভিস টাইমের জন্য ডিস্ট্রিবিউশন টেবিল, এই টেবিলে। সো আমরা এখন খুঁজে বের করব যে 84 কোন রেঞ্জের মধ্যে পড়ে। সো আমরা দেখছি যে 84টা, এই জন্যই হচ্ছে আমরা ডিস্ট্রিবিউশন টেবিলে রেঞ্জ তৈরি করি, যাতে হচ্ছে র্যান্ডম ডিজিটগুলো অ্যাপ্লাই করতে পারি। সো আমরা দেখছি 84টা এই রেঞ্জের মধ্যে পড়ছে, কারণ এর মাঝেই আছে হচ্ছে 84। সো তাহলে এর এগেনস্টে সার্ভিস টাইমটা কত আমরা পাচ্ছি? সার্ভিস টাইমটা 4। তার মানে ফার্স্ট কাস্টমারের সার্ভিস টাইমটা হচ্ছে 4। বুঝে গেছে? সো আমরা আবার পরেরটা করলে আরো ক্লিয়ার হবে। সো সার্ভিস টাইম 4, first customer arrival in the system in clock time 0, so his service start at clock time 0, and service time is 4, that means service end at 4. 0 plus 4 equal to 4. Wait in the queue, first customer does not have to wait in the queue, so the waiting time is 0. Service server idle time, in the meantime server does not remain idle, so that's why it is 0. Total time is spent in the system, so how many time a customer is spent in the system. So we can find out it by using a law, that is the service end minus arrival time. So that's how we actually calculate the times spent in the system. So service end of first customer is 4 and the arrival time is 0. So 4 minus 0 equal to total time spent in the system is 0. Okay, sorry, 4. Okay, so we have done with first customer. Then second customer. So second customer have interval time. Okay, so we have to find out what should be the interval time of first second customer by using the random digit. So you see in the distribution random digit sets, যখন আমাদের র্যান্ডম ডিজিটের সেট দেওয়া থাকবে, ইন্টারভ্যাল টাইম ফর র্যান্ডম ডিজিট যেটা প্রথমটা এটা কিন্তু সেকেন্ড কাস্টমার, বাট র্যান্ডম ডিজিট ফর সার্ভিস টাইমের যেটা প্রথম দেওয়া থাকবে সেটা কিন্তু প্রথম কাস্টমারের। এটা মনে সো এইটা আমাদের একটু মনে রাখতে হবে যে র্যান্ডম ডিজিট ফর ইন্টারভ্যাল টাইম যেই ফার্স্ট ভ্যালুটা দেওয়া থাকে ইট শুড বি অ্যাপ্লাইড ফর দ্য সেকেন্ড কাস্টমার আর সেকেন্ড এন্টিটি, বাট র্যান্ডম ডিজিট ফর সার্ভিস টাইম যেটা প্রথম দেওয়া থাকবে সেটা কিন্তু প্রথম কাস্টমারে বা প্রথম এন্টিটিরই হবে। সো তাহলে আমরা বসালাম 913. So if the random digit for interval time is 913, so let's move forward to the distribution table on interval time. So this is the interarrival time distribution table. So from the table you can we will find out the range. So 913, so you can see that 913 will be fall into in this range 913. So তাহলে এই রেঞ্জের এগেনস্টে what should be the interval time? Interval time should be 8. So we said that the second customer's interval time is 8. So if it is 8, that means second customer arrive 8 minutes after the first customer arrival. So first customer arrive at the system in 0 minutes. 0 plus 8 equal to 8. So the arrival time of second customer is 8. System second customer ta ashlo hocche 8 minute. Okay, fine. So when second customer arrival in the system in clock time 8, he found the system is now idle because the system become idle at clock time 4. So এখন সিস্টেমটা আইডল আছে, তার মানে তার কিন্তু 8 মিনিটেই তার সার্ভিসটা শুরু হয়ে যাবে। So let's now find out what should be the service time of customer number 2. So to find out it, we have to use the random digit for service time. So the second one is for second customer, so we can see it is 10, so we put it as 10, and then we'll move forward to the distribution table for service time, and we can see that 10 is in the range. So and against this range we find out that the service time is 1, so we write down that service time is 1. So the service start of second customer is in clock time 8 and his service time is 1, that means 8 plus 1 equal to 9. Service end at clock time 9, and he does not have to wait in the queue, that's why the clock time waiting time is 0. Server idle time, in the meantime server become free at clock time 4 and then it become again busy at clock time 8. So in the meantime server was idle for 4 minutes, so that's why the server idle time is 4, and the total time is spent in the system, as we said, that is service end and arrival time. So from the chart you can see that the service end is 9 and service began is 8, so total time spent in the system is 1. Okay, so we have done with customer number 2, and now let's find out let us jump and find out the sequence of customer number 4. So we have skipped customer number 3. Okay, so customer number 4, we have used this one for customer number 3 and this one should be used for customer number 4, so 15 from the table. So if the random digit for interval time is 15, let's find out what should be the interval time. So 15 should be in this range 15. So against this range the interval time is 1, so we put that interval time is 1. So it means that customer number 4 arrive after 1 minutes of customer number 3 is the arrival, অর্থাৎ কাস্টমার নাম্বার 3 আসার 1 মিনিট পরে আসছে হচ্ছে 4, তাহলে কাস্টমার 3 আসছিল হচ্ছে 14 এ, 14 প্লাস 4 15 এ, সো কাস্টমার 4 সিস্টেমে আসছে ইন 15 মিনিটস, ওকে, সো 50 মিনিটসে এসে সে সার্ভারকে কি অবস্থায় পেয়েছে, কাস্টমার নাম্বার 3 কে সার্ভ করতে করতে কিন্তু এন্ড টাইম চলে গেছে হচ্ছে 18 এ। রিমেম্বার ইন দ্য প্রিভিয়াস স্লাইড উই হ্যাভ ফাইন্ড দ্যাট if there are only on server, then we have to find out the what should be the service end of previous customer. If it is still going on, then the next customer should be waiting in the queue. So we can see that although customer number 4 arrived in clock time 15, but the service could not be start at clock time 15 because the server is actually servicing customer number 3, and it will end at 18. So at least customer number 4 need to wait at clock time 18, and then the service will be start of customer number 4. So let us find out what should be the service time of customer number 4. So we'll use this one is already used for customer number 3. So now in sequence this will be the next one. So we put that random digit for service time of customer number 4 is 53. So if it is 53, what should be the service time? 53 should be fall down in this range, 53. So against this range the service time is 3. So we write down the service time is 3, and the service start of customer number 4 in clock time 18, because in 18 minutes the server become idle, or in 18 minutes it become free after servicing customer number 3. So and in 18 minutes it start servicing customer number 4. So service start at 18, service time is 3, 18 plus 3, so service end at 21. Now the waiting time, so we can see that the customer number 4 arrived at 15, but the service began at 18, so he has to wait in the queue for 3 minutes. 18 minus 15, so 3 minutes. And server idle time, server become free at 18 and again become busy at 18, so there are no idle time of the server in the meantime, and the total time is spent in the system. So let us now find out what should be the total idle time is spent in the system. So you can see the formula is to find out it, the service end. So service end of customer number 4 is 21, and arrival time is 15. So 21 minus 15 is 6. So that's how we actually find out the time is spent in the system. That means how many time a particular customer stays in the system. So it is depends on the arrival time and the service end time, how in which time the customer arrive in the system and in which time customer leave the system. So that's how actually we compute all the 20 customers data. So same procedure is actually followed, so that's why I am not going to repeat all those things. So if we understand a particular how does we actually compute data of a particular customer, then we can compute all those things. So just we need to follow that in the particular scenario how many customer need to be served. The average waiting time, what should be the average waiting time of the customer? So total time customer wait in the queue. So from the previous slide we have seen that total time is 56 and number of customers, so there are 20 customers, so the average waiting time is 2.8. that means যখনই একটা কাস্টমার সিস্টেমে আসে একটা যারা ওয়েট করে তাদের ওয়েট করতে হতে পারে 2.5 মিনিটস করে। এরপরে the probability that a customer has to wait, that means কাস্টমার আসার সিস্টেমে আসার পরে কতটুকু সম্ভাবনা আছে যে তাদের ওয়েট করতে হতে পারে। সো দ্য নাম্বার অফ কাস্টমার ওয়েট ইন দ্য সিস্টেম, সো আমরা এটা কাউন্ট করবো যে হাউ মেনি কাস্টমার অ্যাকচুয়ালি ওয়েট ইন দ্য সিস্টেম। সো it is actually 13, you can see from the previous table it is 13 and number of customers so 20, so 65, that means 65% chances that a customer when came to the system he need to wait. So 65% চান্স আছে যে আসলেই তাকে ওয়েট করতে হতে পারে এবং ওয়েট করতে হতে পারে তাকে 2.8 মিনিটস। নেক্সট average service time, so total service time 68 and number of customer 20, so average service time is 3.4. Now fraction of idle time of the server, fraction means percentage, so how many percent of time the server is on idle. So we found out it by using a theorem that total idle time of the server and total runtime of the simulation. So total idle time was 18 minutes and total runtime, that means রান টাইমটাকে আমরা বলি যে লাস্ট কাস্টমারকে সার্ভ করে লাস্ট কাস্টমারের যে সার্ভিস এন্ড টাইমটা সেটাই হচ্ছে অ্যাকচুয়ালি ওই সিস্টেমের টোটাল রান টাইম। সো লাস্ট কাস্টমার সার্ভিস টাইমটা শেষ হয়েছিল 86-এ। সো তাহলে ডিভাইড করলে উই ক্যান ফাইন্ড আউট দ্যাট 0.21, দ্যাট মিনস 21% সার্ভারটা হচ্ছে আইডল ছিল। সো আইডল যদি থাকে 21%, তাহলে বিজি ছিল কত? উই ক্যান ফাইন্ড আউট বাই ইউজিং ভেরি সিম্পল থিওরি, 1 মাইনাস 0.21, so it should be 79%. So 79% সার্ভারটা বিজি ছিল, বা এটাকে আমরা ইউটিলাইজও বলি, বিজিটাকে ইউটিলাইজ বলা হয়। সো when it said that fraction means আমাদের আনসারটা হবে হচ্ছে পার্সেন্টেজে, আর যখন আমরা ওদের বলবো যে বিজি বা ইউটিলাইজেশন তখন আমাদের বের করতে হবে হচ্ছে এইটা, আর যখন আমাদের বলবে যে what is the idle time, so idle time তখন total number of idle time আর simulation run time, so এইভাবে করে আমরা বের করে ফেলতে পারি। So we can see that the utilization or the busy time of this server is 89, so which is 79, which is very good. I mean when we are doing a simulation, if the utilization is 80 or above 80 or very close to 80, then we can say that system is working fine. Then there will be some other thing as well, like average time between arrival, so total time, and we know that the first customer does not have any arrival time, that's why the number of arrival 20 minus 1 and 19, so total time between arrival 82 divided by 19, so the average interval time is 4.3, and average waiting time of those customer who really wait. So এটা আমরা বের করতেছি যারা অ্যাকচুয়ালি কিউতে ওয়েট করেছে তাদের কতক্ষণ ওয়েট করতে হয়েছে। সো আমরা দেখলাম যে কিউতে ওয়েট করেছে টোটাল 13 জন, সো টোটাল ওয়েটিং টাইমটা ছিল 56 ডিভাইডেড বাই 13, সো যারা অ্যাকচুয়ালি ওয়েট করেছে তাদের এভারেজ ওয়েটিং টাইমটা ছিল 4.3। সো এইরকমই আমাদের কিছু কোশ্চেন আনসার করতে হবে, অ্যান্ড রিমেম্বার দ্য বার চার্ট অলসো, উই ক্যান ইনক্লুড দ্য বার চার্ট, সো ড্র দ্য বার চার্ট টু depict the system utilization. So that's how actually we simulate a single channel queue, and that's how that should be the particular question or queries that can be asked after completing a particular simulation. Okay, and also including a bar chart, so draw a bar chart like this one. So this is the end of the part 1. I hope you guys understand how to simulate a single channel queue. In second part we will inshallah discuss about how to simulate a system with double server, that means double channel queue. Till then everyone, please stay safe, stay home. Allah Hafiz. Assalamu alaikum.